Welcome back to geometry. We're doing 6.6 today. However, we still have some problems to finish up from the previous lesson. So when looking at these kites, one thing that I think we should focus on is that these two triangles will always be the same. Okay, so these two shapes, so that means all their sides and all their angles are the same, as well as these two triangles in red. Okay, so these two triangles will always be the same. And if you look at the shape, you can just see that symmetry, right? I mean, you know that these two triangles are going to be the same, so all their angles are the same. So we would know that angle 2 has to be 46 degrees because these two angles will each be the same because these two triangles are the same. And so that means if we know that in a kite that their diagonals are perpendicular, that means I can put 90 degrees here. I can put 90 degrees here, 90 degrees for angle 1, and that means angle 3 would be 180 in a triangle minus 90 plus 46, 136, so that gives us 44 degrees. Alright, and then same thing for over here. We know that these two triangles are the same, and then these two triangles will be the same as well. So angle 2 has to be 90 degrees. I can move 90 here. That means angle 3 is going to be 18 degrees. And then angle 1, since these two triangles are the same, that means these two angles are the same. I can move 18 degrees here. And we have 90, and then that means angle 1 is going to be 72 degrees. And these two angles are the same as well. Alright, to our flow chart, remember that we can always flow down. So all these traits will then flow down or get passed on. So when I think of this first trait where it says diagonals will bisect each other, that's going to be true in our parallelogram. Now, since it's true in this shape, it's going to flow down to all of these shapes. So put A, and A. And it's not true in a kite. It's not true in a trapezoid. Next, we have diagonals are perpendicular. That's going to be true in a rhombus. It'll be true in a kite. Now, let's jump back to our rhombus because remember that all of these traits flow down. So since it's true for a rhombus, it's also going to be true for a square. Now the kite has nowhere to flow down. It's its own species, so it's not going to flow down to the trapezoid or isosceles trapezoid. C, diagonals will bisect the opposite angles. That's true in a rhombus. Therefore, it'll also be true in a square. It's not true in a parallelogram or a rectangle. If we think about a kite, we know that these two angles are the same, but when we draw this diagonal, it's not going to cut these two angles in half. It will not do that. When we draw in this diagonal, now this diagonal will cut these two angles in half. So these two angles are the same, and these two angles are the same, but it has to be true for both. It says that two diagonals will bisect the opposite angle. This is only one diagonal, so it's not true in a kite. And last one, D, diagonals are congruent. That's true in a rectangle. Therefore, it'll also be true in a square. And it's not true in a trapezoid, but it is true in isosceles trapezoid. This will be true. Okay, we're being asked to graph snow. So let's graph snow. We're told the shape is a rectangle, so let's find out. Negative 5, 2, I can put a point. Negative 5, 6, I can put a point. 3, 6, I can put a point. And 3, 2, I can put a point. And so we draw our shape, and there's our rectangle. All right, now let's go ahead and label these points. So this was negative 5 comma 2, this was negative 5 comma 6, this was 3 comma 6, and this was 3 comma 2. Alright, we are told that points on the same horizontal line. So these are the two horizontal line. They will have a slope of 0. Okay, and the other thing that I think is very important to write is that, and they have the same y coordinate. And so let's look at that. I mean, here is our x and then y coordinate, our x and then y, and we look at this horizontal line and we see that they both have 6 for y. Okay, and so we look at this horizontal line and I see -5, 2, and 3, 2, and again we see that they have the same y coordinate. They also have a slope of 0. When we go to the vertical lines, that would be these two lines, they are going to have a slope of undefined, and they have the same, and this time it's not going to be y coordinate, it's going to be x coordinate. And so if we look at, again, these two lines that are vertical, we see 3 and 3, we see -3, or sorry, -5 and -5. All right, now we're not going to be doing this yet. We're actually going to be doing this later. But if I wanted to prove that this shape was a rectangle, okay, and let's just say that we weren't given that the shape was, and they ask you to prove that. Okay, well, in order for us to prove that, we would have to prove that these two sides are each congruent, which we can if we count up 1, 2, 3, 4, and 1, 2, 3, 4. And then we count this side, we get 1, 2, 3, 4, 5, 6, 7, 8. I believe that's going to be 8. And we get 8 down here. So we've proven that opposite sides are each congruent. However, in order to prove that it is a rectangle, we have to prove 90-degree angles in every corner. And we haven't done that yet. So in order to prove that, we would have to compare the slopes of each line. And we have a slope of 0 versus slope of undefined. Okay? Now, to prove that lines are perpendicular, we need to show that their slopes are opposite reciprocals. So my question to you is, when you look at 0 versus undefined, are these two slopes considered opposite reciprocals? All right, well, the answer to this is yes, and here's why. If you were to rise, let's say that we looked at our slope that had 0, and we were to say, hey, I'm going to rise 0 and run 1, okay? And then you looked at, so again, this is for our horizontal line. Okay, we have a slope of 0 over 1. Now for the vertical line, we would rise 1 and run 0. Okay, now you can see that these are reciprocals. Now you may not think that they're opposite, but remember, we could make one of these negative and the other positive. Okay, so 0 and a slope of undefined are considered opposite reciprocals. Therefore, we can prove that the shape is in fact a rectangle. All right, next we're going to look at these shapes. And before we continue, usually when we graph, we always graph in x and then y, and that would make sense because, again, when we graph, we usually go on the x-axis first and then followed by the y-axis. Okay, so we would go to the right x and then up y, and so in a sense we always graph using x and y. Well, we can also graph using a and b, okay, or we could graph using c and d. There's many other letters that we can use, but just know that this first term is interchangeable with x and this second term is interchangeable with y. Okay, and this will make more sense as we go. And before we solve these problems, I should have solved the algebra review. So let's go back and solve this as well. These share a 2. I'm going to pull a 2 out. I get x squared minus 16 is equal to 0. And then x squared minus 16 would become x plus 4, x minus 4. We set each of these equal to 0. X equals 4, x equals negative 4. Those are my two answers. Alright, next, these share a 3x, so I'm going to pull a 3x out. I get x squared plus 2x plus 1 is equal to 0. That gives me 3x and then x plus 1 parentheses x plus 1. And then this time, since I have an x out in front, I actually have to set this term equal to 0 too. So I get 3x is equal to 0. I get x plus 1 is equal to 0. And then x plus 1 is equal to 0. Well, these are going to yield the same answer. X equals negative 1. And then this is going to be divided by 3, and x is equal to 0. Moving over to the right, we have 2x times x. We get 7 times 3. That makes it negative, and we make this positive, and we set it equal to 0. So that ends up giving me 2x plus 3 is equal to 0. 2x equals negative 3. X equals negative 3 halves. And then this is going to be x is equal to 7. Alright, on problem 4, this will not factor. So if a problem will not factor, we have two choices. We can use the quadratic formula, or we can use what's called completing the square, which I like to call CTS. Now, in this problem, I wouldn't suggest using CTS because when you take half of this middle term and square it, you end up getting a fraction. So we're going to use the quadratic formula, which says negative b plus minus square root of b squared minus 4ac all over 2a. So a in this problem is 1. It's your number in front of x squared. B is negative 3. C is 1. So we get negative 3 plus minus negative 3 squared minus 4. A is going to be 1 and C is 1, and then that's going to be all over 2 and A is 1. So we end up getting 3 plus minus 9 minus 4 all over 2. That's going to be 3 plus minus rad 5 all over 2, and that's my answer. 3 plus minus rad 5 over 2. Now, if you wanted to separate that, you could. You would get 3 plus rad 5 over 2, comma. So here's one answer if we separate it, and then 3 minus rad 5 over 2. And those are our two answers. Alright, on problem 5, we have 2x squared plus x squared minus x. These share an x. So we're going to pull an x out. Let's do that right here. We end up getting 2x plus x minus 1 is equal to 0. This is going to be 2x plus 2x is 3x minus 1 is equal to 0. And so separating these two, we're going to say that x is equal to 0, 3x minus 1 is equal to 0, and so that's going to be x equals 1/3. So we get 1/3 and 0. Alright, and then our last problem for this will not factor. Alright, D and F does not factor. Alright, next problems. We're going to graph these points, and now we're going to use x, y, and we're actually going to use a and b. So when we start at the origin, this is easy. We can say this point is going to be 0, 0. Okay, now usually we would say that this point would be x and then 0, okay, because remember that points that are on the same horizontal line will have the same y coordinate. So I know that this y coordinate is going to be 0, okay, and usually we use x, but for these problems we're going to change this up now. And again, I can use any letter for x that I want. In this case, I'm just going to call it a, okay, and a is just some number that we don't know. I mean, it looks like, you know, 1, 2, 3, 4, 5, 6 maybe, but we don't know how many marks. So it's just some number that we're not sure about, and since we don't know it, we're just going to call it a. Then points that lie on the same vertical line have the same x coordinate, so this is going to be a comma. Now this time we're going to go up on the y-axis. Okay, and so usually we would say that this is point y. We're actually going to use the letter b for y. All right, so we get a comma b, and then this point would be 0 comma b. All right, and remember that the term vertices means angles. So using variables, label the location of each of the angles of the rectangles. All right, we're going to do the same here. This is our origin. We're at 0, 0. On this point, we went out a on the x-axis, and we're at 0. That means we went negative a and then 0. And why are these the same? Well, remember that the opposite sides are each congruent, and that these two sides are each congruent. So these two lengths have to be the same amount. And then we went we went over a and then up b, and then we went over negative a and then up b as well. All right, before we graph the squares, if we were to graph squares and using real points, sorry about that curved line. Let's say that we had a square that started at 0, 0, went up 3, and then went right 3, and then here's our square. And actually, let's do this in another color. It'll make it easier to see. Okay, so here's our square. Now, since a square has all sides are the same, all of these lengths are 3. So we have a 3 by 3 square. Now, if we were to label our points, right? If we were to label these angles, this is going to be 3 comma 0. This is going to be 3 comma 3. This is going to be 0 comma 3, and this is going to be 0 and then 0. Okay, now I want you to think about this problem, and we're going to then use this knowledge and transfer it over to these problems. Now, we don't know if this is 3 marks, 4 marks, or 5 marks. So again, this first point's easy. It's going to be 0, 0. This point, we're not sure how far over on the x-axis we go, so we're going to call it a and then 0. This point, again, since in a square all sides are the same, and we looked at 3 comma 3 over here, this is going to be a comma a, and then this point is going to be 0 comma a. All right, and just for a few seconds, look at this problem and this problem, and it should make more sense. All right, next, again, we're at the origin. We're at 0, 0. Let's start with this point. In Q1, both the x and y are going to be positive values. So this is going to be a comma a, okay, because they're both positive. In Q2, it's going to go negative for the x and then positive for the y. So we're at negative a comma a. This point is going to be negative a comma negative a, and then this point is going to be a comma negative a. All right, next shape. Let's start with our parallelogram first. It's a little bit bigger, and it'll make a little more sense. We're going to start at the origin. So we're at 0 comma 0. All right, and then for this point, we're going to say that we went over a again, and then we're at 0. All right, these next 2 points is going to take some critical thinking. So let's think about this. If we were to say what point, well, we know that on each of these points, and this is a horizontal line, they're going to share the same y-coordinate, and we know that's going to be, actually, we're going to change it this time, and we're not going to use b this time. Let's erase that. Sorry. We're actually not going to use b this time. We're going to use c, okay, and we'll find out why. And so with this point as well, we know that they'll have the same y-coordinate, which is going to be c. All right, go ahead and draw this line down, and from 0 to this distance. I'm going to highlight this in red. And so what we're saying is that from here to here is going to be B amount. Okay, from 0 to this point will be B amount. So this point is going to be B and then C. Alright, now what I need you to see is that from these 2 points in blue, let's just show that length. Okay, from 0 to A is A. Okay, so how do we get to this point in pink? Well, you're going to take this amount, which was A, and remember that we still have this amount in red, which is B. Well, if you draw this line straight down, this distance right here has to be the same as this distance, and this is going to be B. So to get to this point, we really add up A plus B, and that's how we get out to here. Alright, we're going to do the same thing for the rhombus. We're at 0, 0. Here this point is going to be A, 0. Alright, and we're going to do the same thing that we did in the other problem. This point is going to be B, C. Draw this down, and hopefully you can tell that this length right here is going to be B. So when I draw this length down, this length is also going to be B. And let's not forget that from these points we have A, and then we add up B. So A plus B, and then C. Alright, and again, in case we can't read that, that's A plus B, and then C. Alright, for the kites, this shape was drawn a little bit off. This point is on this angle, same here, same there, and same thing down here. Alright, on our kite, we know that these 2 points will be the same in regards to how far we go over on the x-axis. So this point is going to be A, 0, which means this point is going to be negative A, 0. This point is going to be 0, and then we went up B. And then this point is going to be 0, and we went down, and it's not going to be B because these 2 amounts aren't the same. This length is much longer. This is going to be C, an unknown amount. Alright, name the missing coordinates without using any variables. Again, here we have BC, we have S0. We're at the origin, which is 0, 0. So they want to know point Q. Well, remember that when we come down to here, this length is going to be B. So draw this line down. This length is going to be B. So to get all the way out to point Q, we take this distance, which was S. Okay, so now they've changed it from A to S, and then we have to add up B to get all the way out here. So S plus B, comma, and then we're up C on the y-axis. For the rhombus, all sides are the same, so we know this would be negative A0 because we had A0 on the right hand side, and this will be 0, negative B. For the isosceles trapezoid, we know these 2 lengths are the same, so if I went left B up C, I would have to go right B and then up C. Thanks for joining us. See you next time.